Hello and welcome to the third part of my tutorial series for making a 2D platformer game. The next thing we're going to do and add to our game platforming controls are some more control over speed when we're in the air, and then additionally more control over how fast we go up into the air when we jump and how fast we come down. So let's start with that first one. At the moment, we've got here our max acceleration, deceleration, and turn speed. And then we're deciding which one of these to use based on our calculation of what direction we're moving in. So what I'm going to do is a little thing where I'm going to take these variables that are specific to a particular value and sort of modularize them so that they can be set to one of two different values, one for being in the air and one for being on the ground. But before I do, I'm looking at this and I'm thinking this is a little bit unwieldy, all of these variables. So I'm going to start using headers to separate out these different kinds of variables, as I've already been grouping them a little bit. So we might as well make this look a little nicer in the inspector. I'm going to go ahead and add the square brackets in the header. And then inside, as the argument for the header, I can put the name that will show up in Unity. So in this case, these variables, this little group of variables here that I've also named starting with U, these are the ones that I'm going to just set up once in Unity. So I'm going to say set up once in Unity. And I'm going to copy paste this line of code. We've got our internal variables that start here, which are basically the variables that, are just going to change over time as we play the game, and we're not going to set them up. So I'm going to call this internal variable. And for example, here we've got our jump input and our movement, and then also our desired x velocity. So I'll get rid of these spaces here. Not that the spaces matter when it comes to what the inspector window shows. And these last kind of variables I'm going to call design variables. These are not really like proper names in terms of the standardized way of formatting things, but this is just the way I like to think about things. You can also, instead of making these variables public, you can make them private serialized as well. That's up to you. In this case, though, like our design variables, this is where I like to basically think about these variables as values that we can tweak and change, and then when we do so, that changes how the game will feel to play. So these are the ones we're going to change around. And now if I save that, go back to my Unity project and click on my character here, I should be able to see those headers. So we can see here, these are the setup once in Unity, these are the internal variables, and these are the design variables. We'll pluralize these here. So the next thing we're going to want to do is add some new variables. We're going to go ahead and duplicate all of these max acceleration, deceleration, and turn speeds so that there are ones for being in the air as well. So I'm going to duplicate them and then type in the word air here. So we've got a max air acceleration now, max air deceleration, and max air turn speed. So we've got one of these for when we're in the air, one of these for when we're not in the air. So now if we go down to where these max accelerations are being used and stuff, we're going to create a little local variable, first of all, that we can then swap in and out as we wish. And this is like a template for sometimes changing something that you already have in your code that's running one way and then making it more modular. So in this case, we're going to create a new variable, a local one for each of our types. So for example, we've got max turn speed. So I'm just going to call this turn speed. Max acceleration we'll call acceleration. Also float acceleration. And I'm also just making sure I have these starting with a decapitalized, lowercase, and our float deceleration. Now, with these local variables, we can just set them up to be equal to the values that we would be normally using. So in this case, we're just using it if we're on the ground, the max turn speed. So our turn speed is equal to max turn speed, our acceleration is equal to max acceleration, and our deceleration is equal to max deceleration. And now if we go ahead and replace these in our code, like for example, turn speed and acceleration here. So what we've basically just done is nothing. I mean, the effect of this is to change nothing yet. Our turn speed is now the same as the max turn speed, which is now what we're using here. So, before we had max turn speed directly here, now we've got this extra variable step. But the reason that we do this is because before we use these variables, we can decide to change them to something else. So in this case, we're just going to say, are we on the ground? Is on ground. So we're going to use that is on ground. And because we're checking if we're in the air, we're going to say if not on the ground, which is to say if we are in the air. Then we're going to go ahead and copy paste this and set these all to be the air versions. So max air turn speed, max air acceleration, and max air deceleration. Now we've already defined our variables here, so we don't need to define them again. They already exist for us to change the values of them. So now we've got our code set up quite nicely. We set them all to their default values of being on the ground. If we are not on the ground, then we set them all instead to be the variable values of being in the air. And now we use whichever value we've preset it to in our code. And you'll find that a lot of the times you'll want to write code that uses a specific value of a variable. And then you're like, okay, well, sometimes it's going to be in the air, sometimes it's going to be not in the air. So it will use these different values. And that's how you'll want to solve that issue in your code. So now if we go to save our code and we go down here, we can set our max air acceleration, for example, to a lower value than we have on the ground. In fact, just to demonstrate, I'm going to set my air acceleration to 0 just to show you the effect that this will have on playing the game. So if I go ahead and jump in the air and then try to move to the left while I'm in the air, I just simply cannot. I retain instead the momentum that I had when I jumped. So if you wanted a game, you could set these all to 0, in which case you have a game where whatever your momentum is when you jump, you can't change it at all, right? So like you jump into the air and then you're not allowed to, for example, turn, so your turn speed 0, so you can't control your character in the air. Or you could have a control where you're only losing slight control. So for example, maybe your acceleration is decreased, your deceleration is decreased, and your turn speed is decreased. So you can control a little bit of how much you go in while you're in the air, but not as much as when you're on the ground. That's the typical thing to do. I'm going to set some of these values up here. I was mucking around in between making these tutorials, and I found these values for now. So I'm going to just set these to 2020 max speed. I'm going to set this all the way down to 10. I have this really high. Our acceleration, deceleration, we're going to set that to 10. That one to 20. And our acceleration will set to 10 as well. So you can see you can not control your character as much, but at the very least you can stop moving is the idea with these particular values. These will be, of course, values you can tweak around forever and see how it goes. Now, before we go any farther, one of the things that I've noticed is that even though I'm getting really high frame rate, my character's movement isn't as smooth as I'd like it to be. And we can just quickly increase the smoothness of our rigid body movement by changing the collision detection here to continuous on the rigid body of our character, and also the interpolation to interpolate. And basically what this is just going to do is render and calculate frames more often with our fixed update. So it's more expensive, which is why it's off by default. But we only have one player character, and we want them to be as smooth as possible, rather than like thousands of rigid bodies, in which case we'd want to save the frames as much as possible and make it more expedient. So we've got our control of the character in air being worse than on the ground, or theoretically you could do it the other way around, depending on what those values are. But we're now going to go ahead and add some new variables to our design variables. We're going to, at the moment, control the jump simply with just the jump height. But what if we want to fine tune our jump a little more than that? For example, let's say we look at our jump now. Our jump height just is setting, so if I set this to a higher number, then it takes quite a while to jump to that height. And you also the character falls down at a very specific rate as well. So let's try and tweak those two things, and this will get very complex very quickly. So I'm just going to basically take you through implementing this first, and then I'll try to explain it. So the first two values we're going to need are the values that we're going to plug into everything else. We've got our time to jump apex and a downward movement multiplier. So this time to jump apex is basically what we're going to use to say how long should it take for you to go from standing on the ground to the top of your jump. according to a height that we've already set. And then the downward movement multiplier is going to be a bit more straightforward, which is just how fast should we fall back down, which is to say how much are we going to multiply gravity by when we are falling. So how do we actually achieve the goal? So the first thing I'm going to go and do is go down to my fixed update here and go all the way past down to the bottom here of our fixed update. And I'm going to say that we're going to check for two different things. So we're going to check our rigid body velocity. So I'm going to do my U rigid body. And this is after I've set everything else in my code. So I can get my velocity at Y. And now if my Y velocity is 0, then my character isn't falling. But we can go ahead and say if it is less than minus 0.01, so like a really low value, but nonetheless a negative value, then we know our character is falling. Now we're going to create a new internal variable here to keep track of what our gravity multiplier should be. So I'm going to call this grav multiplier. Let's try that again, multiplier. Something like that, anyway. And this grav multiplier we're going to set based on whether we're falling or not. If we're not falling, we're just going to set the gravity multiplier to 1. If we multiply something by 1, generally speaking, that just means that we're going to set it to what it was before. So normal gravity, basically, if we are not falling. However, if we are falling, I'm going to go ahead and set my gravity multiplier to my downward multiplier. Now, this doesn't do anything yet, but at least now we have a gravity multiplier, which is going to be correct relative to whether we're falling or not. So now we're going to go all the way up to my fixed update because, we're going to go up to the update instead of the fixed update now for actually setting our gravity and calculating it. So we're going to calculate a new gravity. And this is to control what, our falling and jumping height speed. We're going to set it equal to a new vector 2. The first argument of our vector 2 is going to be 0 because we're not moving on the x-axis at all. And now the second is going to be a little more complex. The first thing we're going to do in brackets, so that this gets calculated separately, is we're going to multiply -2 with our jump height. Now, why are we doing that? Well, basically, if you recall our complex maths before, which was that we had the square of something, the square of -2 multiplied by something. Whenever we square stuff within the context of momentum physics, jumping up and down, it's basically because we don't have a linear graph. So instead of, as the jump height increases, the amount of gravity we need increases linearly. So like with a jump height of 4, we need a gravity of 4. With a jump height of 5, we need a gravity of 5. Instead, it's more like with a jump height of 4, we need a gravity of 8. And with a jump height of 8, we need a gravity of 16. So, like these values are not linearly connected. They're instead connected by what is usually like a squared graph. So if we go back to our value here of a new gravity, we are trying to work out from our jump height what kind of gravity we're going to need. So by multiplying -2 by our jump height, we are doubling essentially what our jump height is, and I'll explain why it's a negative value in a moment. Now we're going to divide this value by our time to jump apex, and I'm pretty sure there's a math function for squaring stuff, but for now I'm just going to be lazy and do it in long form, multiply it by itself. So again, we're using this kind of concept of squaring something, and I'm not going to go too far into the explanation of this, but basically we're taking our time to jump and multiplying it by ourselves. So the longer the time is to jump, the greater this value will be, right, on a nonlinear square graph, which means that whenever we divide our gravity, we are making this a smaller value, right? Now, you're going to notice that we do end up with a negative value here for our gravity, when really we want this to be a positive value that we put inside our rigid body dot gravity scale. So the gravity scale, it's normally 1, and we can increase it and decrease it. So the higher the gravity scale, the more gravity we're going to get. So to turn our negative number into a positive number, we're going to go ahead and take our new gravity dot y, which is going to be a negative number here, and we're going to divide it by the normal gravity that exists, which is our physics.2d.gravity.y. So the normal gravity that exists, if I go back to my player project settings here, and I go to physics, you can see that the regular gravity is minus 9.81, and this is based on like real life physics, where the units in Unity, I think, are a meter each. So one scale is 1 meter, I think. Maybe it's feet. I'm pretty sure it's meters. And this is the minus 9.81. This is the standard gravity. So if we go ahead and take our gravity and divide it by minus, and we already had a negative value, this will create our new positive value. And the last cherry on the top is we're going to go ahead and use that gravity multiplier that we had before, which is either going to be 1 if you remember, or it's going to be a higher number if we're falling. So we just multiply our gravity by this number. So if we're falling, the gravity will increase, so we'll fall faster. So hopefully this is it's very hard to understand, and I do recommend, if you want to, checking out those links in the previous video to try and understand some of this sort of like, why are we multiplying it by 2, why are we multiplying it by itself. But basically the value that we need for our gravity is a negative value, even, and you can consider that almost like it's a positive value. The greater our jump height is, the greater the amount of gravity we'll need to retain the same timings and everything with the same with a higher jump. And then the greater the time to jump is, then the lesser gravity needs to be, because it's just going to need to take longer to jump to that height, which means that we need less gravity, or else we would need more speed and so on and so forth. So let's go ahead and save this and go back to our Unity project. Before we run, I'm going to go ahead and set my very strange things will happen if we have these at 0, because our time to jump would be at nothing. So I'm going to set this to 0.3 at a very small jump speed, and our downward multiplier, I'll set that to 2, so it's twice as fast to fall than it is normally. So you can kind of see how this is working. If I set my jump height to be higher, oh, okay, that's maybe way too high. Let's say we set it to a little higher value, and then we increase it. We should still spend the same amount of time to get to that apex. Our time is still going to be 0.3. And you'll know that our algorithm is working because you can see our gravity scale here, which is 4.5, whatever. If we increase our jump height, you'll see the gravity decrease. You'll see the gravity increase, the gravity scale increase as the jump height increases, because we need more gravity to counteract. And you can also see it double whenever we start falling down. So it's 10 at the moment, and then whenever we start falling down, it will be set to 20. Plus, if we increase the time that we need, we can see the gravity is going way, way down. So like if it's going to take 3 seconds for this entire jump, we're going to need a really low gravity. Ooh, it looks like everything's in slow motion. So now we've got some fine tuning for our jump height, our jump speeds, basically, jumping up speed and falling back down speed. There's just one last little thing I'm going to add for this particular video, which will be a jump buffer. There's lots of other different things we'll start adding to our character to make them feel nice and smooth, but we've got quite a lot of the fundamentals now at the moment for our character done with this complex code. So I think it's a good idea to start really trying to work out what these values should actually be now with your gameplay. Let's go ahead and add a little input buffer. So at the moment we've got our jump input set up nicely in such a way that implementing this buffer won't be too hard. But we're going to need 2 different values. We're going to need 2 different variable values. The first one I'm going to do is an internal one, which we'll call the public float jump buffer timer. And the other one will be a design variable, which will be our jump buffer time. Subtly different. The buffer timer is just what we're going to use to keep track of our buffer, and the jump buffer time is what value we're going to decide we're allowed for our buffer. So basically, whenever we jump, as well as setting our jump input to true, I'm going to set the timer equal to the time. So this will basically say we are now starting the timer. And how much time have we got? Well, we've got as much time as we set in this value here, in this variable. So now from now on, if the timer is going, we're going to go ahead and do an else here, because we're not going to do this on the frame that we do start the timer. But from now on, our timer is now going to count down time minus equal time.delta time. In fact, let's go ahead and make this an if else. So this only happens if the timer is greater than 0. Now, we don't technically need this greater than 0 thing, but it just means that this timer won't just keep going after it reaches 0. It won't just keep going less and less and less and less, which is probably fine, but whatever. So now we're going to go ahead and check, and we're not just going to automatically set our jump input to false. Now, if we do go ahead and use the jump input to actually jump, so if isGround is true and we do get to jump, then we'll set it to false. So we'll just go ahead and copy paste that in there. But let's put an else here. So if we tried to jump basically and we couldn't jump, instead of just setting it to false, we're going to first check is the buffer timer greater than 0? Because if it is greater than 0, then our buffer is still active, and so we'll not set it to false again. And in this case, we're actually setting it to false inside the if statement, so I'm going to invert that and say, is it less than or equal to 0? In which case, yes, okay, you're allowed to turn off our jump input. So the jump input will linger around if we fail to jump, and it will just keep on checking every frame if we can jump now. Can we jump? Can we jump? Can we jump? And we'll keep checking every frame until eventually either we do actually jump and it gets set to false, or the buffer runs out and it gets set to false. Those are the only two ways now our jump input gets set to false. Now that I've saved that code, I'm going to go to my jump buffer time and set this to a very generous value, to say 2 seconds, which is ridiculous, but I'm now going to test this by jumping, and then I'm going to press spacebar very quickly. Let's increase our jump height here and jump time a little. So if I jump and then press spacebar, and then press spacebar again, so you'll see that once we land and we can jump, the character will jump again. We probably in reality want this to be a very low value, like 0.1, so this doesn't kick in unless I hit spacebar right before I hit the platform. So you probably want a very small buffer, so it's only subtle. The player won't even notice it. They'll just think that they are good at timing their jumps when really they are being given a slight buffer. Oh, I'm noticing that our character is rotating as they fall. Maybe you want this, but you probably don't, because we're going to replace this static image with the visuals of our character. So for now, what I would just do is, not while it's playing, but go to constraints and freeze the rotation on the z-axis of our character. That way, if we stand on the edge of the platform, we won't rotate. Oops. Yeah, I still need to tweak these values, I think, to make them feel a little better. If I stand on the edge, my character doesn't start rotating, and it'll just fall off the very edge, like so. All right. Well, I hope this has been helpful and a good explanation into trying to make a platformer that isn't just the bare basics of shunting something around with a rigid body. I will see you all in the next video.